Hello. All right.
Well, I can try going through that and installing or updating whatever that SSL library is. But I guess in the meantime, I don't really need this for, I don't know, a week or so when I start working on the second part of the homework. So I guess it's not super urgent, but potentially other people will run into this. Like I've installed this following the CS 106B and 106L instruction thing.
Yeah.
So presumably someone else with the same installation in Ubuntu should see this error.
There's actually someone else that reached out, but they actually just have a slightly different error, which is interesting. Ellie, I think if you're able to follow the Qt documentation, this should work. But if
Okay.
not, let me know and I can find a clear article for you.
Okay, thanks.
All right, so I was gonna throw these out, but I think I'm just gonna pass them out at the beginning. So, so these are pineapple cakes. For every section I've done, I've always had a section. It's usually like after the midterm where people stop showing up. Then I bring pineapple cakes, and yeah. So I'm from Taiwan. These are like the like a super big part of Taiwan. So if you're interested, try a pineapple cake. They're good. And what else do I have to say about pineapple cakes? Pineapples in the U.S. they're labeled as exotic fruits apparently, but no, trust me, they're really good. So, anyone want a pineapple cake? Okay, cool. So flavors wise, there is a cranberry flavored, and then everything else is kind of original flavor. Okay. I don't know, something. And then these are a little smaller. This one feels a little larger, and this one's really long for some reason. All right, so I'll just go around, and if you have a preference, let me know. Preference?
It's just innocent.
That's not helpful.
Cranberry.
That isn't cranberry. Okay. Okay, you want pineapple cake?
Yeah.
Flavored? Oh, okay, how about this? Just say a random number between 1, 2, and 3, or cranberry. Go.
3.
3, okay. 3 is this. Let's do this one. Catch.
Did you give away the original one already?
I've like a lot, so don't worry. Yeah, this is supposed to last this weekend, next week. You want one?
I'll take that. Y'all take the original.
Which kind?
Oh, there's multiple.
Alright, I'll just throw this one to you.
Whatever. Yeah. Thank you.
Okay. Also, I probably shouldn't throw them because they're also kind of crumbly, so maybe. I'll come back around. Do you want one? Yeah. Do you want one?
What are these?
Pineapple cake.
It's good.
Okay, if you want one, everyone gets one. So, but I want to go through this quickly. So, yes, no.
Yeah.
Okay, just to make it faster, I'm just gonna bring this whole thing around and ask if you want one. This is faster. Alright, you want one? Later. Okay. You want one? Don't worry, I'll come back around. You want one? No? Yes? Yeah, yes, okay. You want one? These are cranberries. Okay. So no one likes cranberry? You want one?
Sure, thank you.
I want cranberry.
I'll change it around.
Okay, here you go. Get more. Yeah, I always bring these after the midterms, so most people don't show up. You want one?
Which one do you like?
I mean, I've had these for a while, so
I'll take the original then.
kind of original.
Okay. Thank you.
Cranberry? Yeah, sure. You want one?
Can I have the right?
The
Middle one.
your right. This one.
Yes, the middle one.
The long one?
The
This one. Okay. I'm like, your right or my right? You want one?
Yeah, and you're good.
And you're good? Okay.
Thanks.
Do you want one? Is this one okay? Okay.
This is so nice of you. Is this
I was gonna save this for next week, and I was gonna get Halloween like candy, but then I was like, it's so cold outside.
Thank you so much.
Yeah, no problem.
Thank you.
Did you get one already? Did you get one already? Oh, you got one. Okay. Do you want one? What flavor? The original. The long one? The not long one. Okay. And I won't throw it. Anyone else? Who hasn't gotten one yet and wants one? Okay. What flavor? Great. Anyone else? Pineapple cakes. What flavor? Original or cranberry?
Original.
There you go. Anyone else want one? Great. All right, let's get started. All right, and if you just came in late, you can always grab one at the end. All right. Cool. Oh no, there are more people coming in. Okay, I'll get more treats next week. All right, so operators. Today we're gonna talk about operators. All right. Okay, today we're gonna talk about operators. Today is not a code-heavy class because overloading operators, there is like a syntax for it. I think it was even written on the 106B slides. So like the syntax for it is pretty straightforward. But the question is more about like class design. When do you want to overload an operator? If you are overloading an operator, what are some typical principles you have to follow? Okay, because C++ will let you overload operators for and have them do weird things. Okay, you can overload an operator and tell it to do really weird things, and C++ will compile. Right, so we're gonna talk about more like design choices. How do you decide how to overload an operator? What should an operator return, etc. Okay, great. Before I go on, 106B students, how was the midterm? Thumbs up, really? Okay, cool. All right, so today we're going to talk about operator overloading. Then we're going to go through a lot of examples. I call these canonical forms. These are essentially the most common types of operator overloading that you'll see. And then we're going to talk about this thing called POLA, and it stands for a really funny principle, and we'll talk about that later. So first, let's talk about operator overloading. Just as a quick challenge, you have 30 seconds with a partner. Try to name as many operators as you can. Go.
Alright. Add star.
All right. Okay, so I'm hearing a lot of good operators. I'm not gonna ask you to name a lot of them. I'm just gonna ask, what's the most exotic operator you can think of?
Define exotic.
Exotic as in, if you say, oh, this is an operator, people will be surprised. Oh, that is actually an operator? Okay, so the kind of like the alligator ones, right? Yeah. Okay. Sure. So the alligators that we used for C out and C in, those are actually operators. So great. Any more exotic operators? No. Okay. One of the most exotic ones is the comma. The comma is actually an operator. Yeah. And there are very rare uses of the comma operator. But so there are like 60 something operators, and around 40 of them you can overload. Okay, I'm gonna explain what overloading means, but today we're gonna be going through this list. All right, one of the most important operators is in purple over here. Okay, the equal sign. That's called the assignment operator, and that operator is very complicated, and that operator is gonna be the whole topic of next lecture. So we'll be ignoring the purple one right now, but we're gonna be going over the ones colored right now. Okay. These are the ones which are very commonly overloaded, so these are the ones I want to talk about. The other ones, like the comma, not really commonly used. Did you know that new is actually an operator, and you can overload new? You can redefine what new means. Now, I'm not saying that you should redefine what new means. Kind of like you can technically redefine what double ampersand means. So it no longer means logical and, it means something else. Again, not a good idea, but you technically could. Yes, question.
When you say like overload an operator, are you meaning in relation to like when you're using a specific class? Or do you mean like for your entire script? Like,
Good question. So that's this slide, which I'll talk about. Okay, but but you bring up a good point, which is all of these operators, they have specific meanings for all C++ primitive types. Okay, so for C++ primitive types, the arithmetic operators, you all know what they do, right? The bitwise ones, if you take CS 107, you'll understand how the bitwise operators work. Relational operators, you've been using that a lot, and they exist in pretty much every programming language. We've been using the stream operators, although we haven't used those stream operators on primitives. If you use it on primitives, those are like bitwise shift operators, also a 107 topic, which we won't cover. The increment operators, these are operators which work on ints, and you've seen them in every loop that you've written. And then finally, these memory ones, you've seen them when you're dealing with pointers. Okay, so for primitive types, these operators work exactly as you originally thought they worked. But the question, so something like this. But the question is, okay, well, suppose we were dealing with a vector, right? And then we're using this like bracket operator. How does C++ know that when you are using the bracket operator on a vector, you actually mean, oh, I want to index into the vector, right? Because the vector is not like a built-in C++ primitive, someone had to have originally said, okay, whenever I use the bracket operator, what I mean is I'm trying to index into the vector. Similarly for this, let's see, for the plus equals, right? When you do plus equals, what does it mean when you're accessing like an element here? So here it's a string. What does it mean to plus equals to have a string plus equals some other string, right? Yeah, appending. So whoever wrote the string class said, okay, the plus equals here means append. All right, but you can also imagine, you can define plus equals as something else, right? I can add the ASCII codes together, which wouldn't make a lot of sense, but like someone had to have decided, okay, plus equals for strings means append, okay? So when we write our own classes, you can also decide what each of these operators mean for your own class, okay? Now, when we actually use these operators, C++ will actually be calling these functions. Okay, so each operator has an associated function associated with it, which is doing the same thing. So for example, let's look at this line. This bracket operator that you see, before here we were doing v bracket 0. Can actually be reinterpreted as v dot, and we call this member function operator bracket with the argument 0. Okay. Now the shorthand form is what you usually write, but the C++ compiler turns it and says, okay, I will be calling this function every time you use an operator. And as you can imagine, when you are overloading an operator, you will be writing a function that has this signature on it. Okay. Any questions? Yeah. Cool. So other things to note, cout is a stream. So streams also have an operator alligator function. And you can chain them as well. So v.operator bracket 1, this will return something. And then that something you can call an operator plus equals to get something else. So this thing returns a string, right? Here, this thing returns a string. And then we can take that string and call the operator plus equals. Okay. Here is an alternative form, which is for a lot of these binary operators, like for example, we're calling cout on some other value here. There's actually a second form you can write them, which is like this. These are now non-member functions. These are like free functions, not part of a class. You can say operator, which takes in 2 arguments, cout, which is a stream, and this thing, which is a string. And you're saying, okay, call this operator on when the left-hand side is a stream and the right-hand side is a string. Okay? Both of these work. and we'll be talking about which ones to use and why. Okay, at this point, do you have any questions? Yeah, question.
Just a super small point. So like, when you do the bracket 0, how does it know that like the 0 goes inside the brackets? Whereas like with the like plus equals, it goes on the right hand side. Is it just like built in?
Yes. Yeah. So it is just built in. Yeah. So a good question. The question was how do you know that like here the 0 inside the bracket, that is like a parameter that is put in here. But then for plus equals, there's a left hand side and right hand side. How do you know that the right hand side is over here? That's just part of the built-in syntax for the bracket operator.
You can think about it as if they wanted to, they could have completely chosen to represent it instead as like v bracket 0 and just have that mean as indexing into the 0. So this is just like a design that they chose.
Yeah. I also made a small mistake here. Let's see. The mistake I made was here. Notice that I specifically did not write this as a binary one, and this should also be v dot operator bracket 1. Okay. There are some operators where you cannot write as non-member functions, and I'll go over that as well. Okay. So yeah, indeed, for this code to compile, someone in the STL must have written functions that look like these. Okay, so for example, someone must have wrote a free function operator alligator, which takes in an O stream and a const val and a const string. Okay, someone must have written this so that when you try to print a string to a stream, the stream knows exactly how you want the string to be printed. Similarly here, the person who wrote the vector string class must have said, okay, when you say bracket, you're actually taking an index and you're indexing into the vector. Okay? How are we doing so far? Good? Okay, so let's just go through some examples, and we'll actually write some of these. So on Piazza, I've posted the lecture code for today. Today is not a code intensive day, but those are just the code for the string vector and the fraction class. Okay. On your own time, I encourage you to look more into the string vector class. Anna will talk more about the string vector class in a couple weeks, but all we're doing is we're trying to add some operators to these string classes. Okay. So first, we start with a string class. Let me just write the code here. Okay, so here's our string class, but I'm basically going to write a program which uses our string class. Oops. Main.cpp. Okay, so you can see here that that I create a vector string. I'm not using the STL library because I actually wrote this string vector, and then I'm just going to do what you expect you can do. So I'm going to push back hello, push back world. Okay, and then if I do like a for each loop, on string s in vec, and I'm just gonna cout s. Okay, what do you expect to be printed? Awkward. Okay, what do you expect to be printed up here? Hello on one line, world on the other line. Right? Okay, this is exactly what you think the vector class works. Okay, so do you make? Oh no. Vim fraction. Okay, give me 1 sec. Let me just fix something here. We will talk more about this part later. I forgot to edit it out. Explicit. Did I not? Vim fraction.cpp. It's the conversion operator here. Okay. Okay, there we go. Operators. There we go, hello world. Okay, and what we want to do is we want to be able to overload the plus equals operator so that it works basically like pushback. So you know how in the Stanford library, if you don't like the method add, you can always do vec plus equals ito n vec plus equals 16.9 ounces, right? You can do something like this in the Stanford library, all right? Interestingly, the STL library, I don't think has the plus equals operator overloaded, so you might want to think about why. But what we're going to do is in our string vector class, we're going to just overload the operator so it supports those, okay? Cool. So yeah, so exactly we're gonna do something like this. We can also overload a second version of plus equals, where instead of taking a string, it takes in a whole separate vector. Okay, and if you use the Stanford library, what this would do is this would take the second vector and append it to the end of the first vector. So you basically combine the two vectors into one large vector. Okay, cool. So we're gonna write those operators right now. So we're gonna have to write these functions to basically tell C++ that when we are doing plus equals on this member vector string, what does it mean? So here, I haven't told you what the return value is, and I haven't told you what the parameter type is, although it's some sort of element. We are taking the element and we're just pushing it into our vector. Make sense? Okay, now there's a lot of other stuff going on, and we'll talk about what to put there. Similarly, over here, we're just in our vector class, we're saying, okay, other is probably some kind of vector. We're gonna just go through the entire vector and just add all the values into our current vector. Okay, does this code make sense? Okay, the key part is just ignore all the other fluffy, this brackety stuff. Ignore that right now. Does the core idea of this line and this line make sense? Okay, that's like the meaty part of the operator overloading. We're taking another vector, going through it, and just adding it to our current vector. Okay, so now what's interesting is, okay, but this operator needs some sort of return value, and it also needs some, like, what type do we give the element? Okay, let's start with the easy one. What type do you think this element is? Okay, so it's a string, but how are we passing this string? So here, const string. Any other ideas? Okay, so non-const reference. Any other ideas? Oh, okay. So the ideas I've heard are you can do a const reference, you can do const without the reference, you can do reference without the const, and then I think the very first thing that was said was just a string without any const or references, right? So there's 4. Which one is the best? There are 2 that work, and 1 is the best. Okay. Yes. Mm-hmm.
Maybe const by reference.
Okay, const by reference, and why do you say that?
Because then you don't have to recopy the string, and also
Mhm.
you don't need to do any modification to
Mhm.
the original.
Okay, yeah. So I totally agree with the reference part. You don't want to copy the string, even it might be like a gigantic string. Okay. The const part though is interesting in that if I don't specify const, let's see. Let's try writing up the code. Oops. Vim string vector.cpp. Okay. So let's implement the plus equals operator here. Okay, so some return value, I don't know what it is yet, and then operator plus equals. This is in the string vector class, so don't forget to write that, string vector : : and then here we want to, you said we wanted to do const string reference. What do I call the parameter? Element. Okay, let me just quickly copy the code there. You push back element. Okay. This const is pretty important, and this is not just a like, oh, it's good style to put const when necessary, but this is actually important for correctness. Can anyone see why? Oops. This const you see over here is important. Yeah. Mm-hmm.
If it was like const at the next level up, and you're trying to call this function, it was non-const.
Mm-hmm.
You get an error.
Yeah, exactly. All right, exactly. So we have to label it const over here because if whoever is calling this function has themselves a const string, then they won't be able to pass their const string into this non-const function. Okay, so for example, if in main I had a code that looked like this, suppose instead I called, suppose I wanted to have a string, const string, s equals ito n, right? This code wouldn't compile unless I also labeled the parameter as const. Because I'm trying to use a const string as the parameter, you can't put a const string into a parameter which accepts a non-const reference. Does that make sense? Question, yeah.
I've never seen something be passed in not by reference but with const.
Mm-hmm.
What does that do, and how is that different from just passing it in without const or by reference?
So just a const without the reference, that means we're making a copy because we're passing it by value. But then you're still labeling that copied value as a const variable.
So if you tried to modify that within the text, then it would throw an error?
Mm-hmm. Yeah, exactly. I can't really think of any cases where that is important, because the most important thing about const is to make sure that like the interaction between whoever's calling the function and the function itself is consistent about, like, is agreeing on whether or not I'm allowed to change the value itself.
And that's only important if it's passed by reference?
Yeah.
You're saying?
Yeah. So if it is just if this was a non-const and not by reference, oops, not that one. If this one was non-const and not by reference, then the code we wrote here would work, because what happens is the function itself would copy s, would make a copy of s. So it doesn't really matter in that case. Okay. Sure. Question. Yeah.
How many like bits does const take up?
Let me get to that. Can I talk about that after lecture? Because it's a good question, but it's not directly relevant into what we're talking about.
For ints, my section leader said like you don't want to pass it by reference.
Mhm.
Yeah.
Yeah, let me talk about that. Yeah, because that has to do with more 107 stuff. So I'll talk about that next. Cool. So, okay, so now the hard question is, what's the return value? Okay, so I'm hearing a Boolean. Okay. So the interesting thing to think about is when you overload these operators, think about what would happen if you were using these operators on regular ints. Okay, so suppose I had a variable I, that was an int, and I did I plus equals 2. When you do I plus equals 2, something is actually returned from that statement. Anyone know what it is? Yeah,
Is it the new value of I?
It is the new value of I, but we're not creating a new value. It's the value of I itself. Yeah, so we add 2 to I, but then the return value is the value of I itself. Okay? Yeah, so it is an int, but it's not just an int, it's a reference to an int. And it's a reference to the I that you just added to. Okay, to clarify that, let me just write some code that, like, this should be valid code, even if it looks weird. Oops, no. Main.cpp. Okay, so I should be able to do vec plus equals s, and then I take this return value, and I do plus equals 16.9. Oh, let's do green tea. This code should be valid. Okay, if vec was an int and these were other ints, this code would be valid. Basically, what happens is we add something to vec, and then this expression will return a reference to the original vector. Then we add another thing to that vector. Does that make sense? Because for primitives, plus equals will return a reference to that value itself. You should also return a reference to the object itself if you're overloading plus equals. Make sense? Okay, just to clarify what I mean. Oops. Yeah, the return value here should be a vector, a reference to a vector of strings. Okay? Oh, okay, sorry, I made a typo here. This should be a string and a vector of strings. Originally, my example was int, but then I changed the code to string, so these should be strings. Okay, any questions? Yeah, uh-huh.
These already a pointer?
This, yeah, so this is a pointer. This was covered in 106b, right?
I didn't
Okay. Is this covered in 106b?
It will be.
Not yet, really?
An instance of it making an array.
Okay. Okay, so this essentially just refers to, this is a pointer to the current object itself. Okay, so for example, in the code over here, if I used this inside the class, this is referring to that vector itself. Okay, and then we're returning a reference to that vector, so we don't want a pointer, we have to dereference that pointer. Does this make sense? Okay. This is pretty. This is not easy to grasp on the first look, and this is a really important part about operator overloading, which is you constantly have to be thinking about. Okay, should the return value, should it be by reference, by value, or by const? The parameters, should they be by reference, by value, should they be const? Okay, so this is very important to understand right now why these have to be references. Do you have any questions at this point? Okay, just a pure hypothetical. If I removed these references, what would the result of this code be if I tried to print out the strings? So if it is by reference, then this should print out ito n, and then a new line, green t. But if it's not by reference, what happens? Raising your hands. Yes.
Just go ahead.
Exactly. And can you explain why?
It creates a copy if you're not manipulating the actual memory.
Mm-hmm.
Then you're trying to print out. So the vector doesn't actually get manipulated.
Yeah, exactly. So if we don't return it by reference, then what vec plus equals s does is it adds s to the vector, but then it returns a copy of that vector. When you do plus equals green t, you're adding green t to that new copy. Okay, and then that copy is gone once the statement is done. So when you actually try to print out vec only has s in it, which is ito n. Does that make sense? Okay, there are a lot of really weird, unexpected uses of C++, but you will be surprised at how often some people write code like this, which is really confusing. So when you write your own classes, you have to assume that whoever is writing the class can do weird things like this, and you have to return the correct semantics. Okay, so here we have to return references. Okay, conceptual check. Why are we returning a reference? We just showed that. Why are we returning this? Okay, we explained that. Okay, so the question is plus equals. Plus equals technically takes in two operands, right? It takes in the vector itself and the string that you're adding, right? But in our function here, we only see the right-hand side. Where did the left-hand side go? Right? When we write this code over here, the right-hand side, the string itself, shows up over here. This is supposed to be string. But the left-hand side, the actual vector itself, let's make it easier. Vec over here. Where does the vec show up in here? Yeah. Mm-hmm.
In this?
Yeah, exactly. So remember that because these are member functions, these functions are being called on some vector. And that vector that you're calling on, that is this vector over here. Okay? This line is the same thing as vector.operator plus equals green t. So the left-hand side is the implicit function that's calling. And in C++, you can retrieve that object using this. This is a pointer to that object. Okay, any questions at this point?
One quick question.
Yeah.
So just pushback was just a member function that you define somewhere.
Yeah, exactly. So pushback is a member function within vector.string. Yeah. Okay, let's move on. Okay, I'll skip that. Questions, I already asked this. I have a new symbol now, avocados. Okay, we wrote, okay, let's do an example where, okay, instead of doing plus equals, let's implement plus. Okay, so in the Stanford library, I think, you can take a vector and another vector and you can add them. What happens when you add a vector to a vector? Yeah, that thing should return the two vectors appended together. Okay, but quick question: does it change the two vectors that you initially added? No, right? So if I did something like this, string vector vec1 ito n, string vec2 is green t and 16.9 ounces. Okay. If I say well, I don't want to do C out. String vector vec3 is equal to vec plus vec2, right? This returns a vector which has all the elements appended, but it doesn't actually change vec and vec2 themselves. Does that make sense? So if we were implementing this in vector.cpp, here, return this, and this should be a string vector. Okay, so if we were implementing the plus operator, so string vector operator plus, what should the parameter be? So it's definitely two vectors, right? Because we're trying to say what does it mean when you say vector plus vector. But how is the vector const qualified or reference qualified? Is it, do you pass in both vectors by value, pass in both by reference, by const reference?
Wouldn't you still do const reference?
We would do const reference here, right? Because these vectors, even after the plus operation, they should not change. So string vector, vector v1 const string vector. Oh, actually, so this is a member function, so we're actually just going to do other. Okay, so the first vector is the vector, the implicit this, and the other vector is other. Okay? And what's the return value of the plus operator? It's a string vector by reference. Not by reference, right? Because when you do the plus, you're creating a new vector which has both of those combined together. Right? It's not a reference to either of the original vectors that we were given. Okay? All right. How do you implement this? Yeah. Uh-huh.
You need to make another string vector first, and then append like star this, and then the other.
Okay. So we do that, and then we do for these are strings. Const std string s in other. We just go through other, and we just do result dot push back s return result. Okay. So here we make a copy of this because we don't actually want to change this itself. We're making a copy of this, and then we add the other vector's strings into S. Okay, make sense? We'll talk about more about this operation later. This is called a copy assign. This is called a copy constructor, and this is where the important equal sign comes in. Question? Yeah.
Could you also use the plus equal you defined before? Like
Yeah.
instead of-
Good point. We could do this as well. Awesome point. Yes.
So do you need to define the equal sign first?
Yes. So this code technically wouldn't work because there is something wrong with the equal sign. That's next lecture. Yeah. Basically, the plan was by the end of today, I'm going to point out that this doesn't actually work, and it's because of that equal sign. So let me save that for later. But yes, this code doesn't technically work. It works if we fix the equal sign, but the equal sign doesn't work, and we'll discuss why the equal sign doesn't work by default. Okay? All right. This is missing one more thing, which is before originally I wanted to write this as like a non-member function with both parameters, both the first vector and the second vector. Here we put the first vector as the implicit this. But technically inside this vector we can technically still change this, right? How do we prevent changes to this inside this operator function? I'll give you a hint. It's definitely a const, correct? It's definitely a const somewhere, but where do we put the const? Yeah. Yeah, we put it here, and we say that this method is const. Okay. All right, let's go back to the code. All right, so yeah, this is basically the code that can be written for that. And then, okay, but here's the thing. Here we declared this as a member function. it is actually better to declare this as a non-member function. Okay, so as a non-member function, what would this look like? It would look something like this. First, string, vector, second. Okay, so this is not part of the class anymore. String vector result equals first, and then for const std string s and other result plus equals s return result. Okay, so we have two possible ways to write this: first as a member function, and second as a non-member function. Yes, probably second. Yes, second. Thanks. Okay, which way do you think is better? Oh, tough question. Which one's better? Okay, I actually don't expect you to know the answer away, but I'll explain why this second one as a non-member function is better. And the reason for that, do I have it on the next slide? Okay, I won't get to the reason first, but I'll first get to the general rule of thumb. Okay, do you implement an operator as a member function or as a non-member function? Okay, so the rules are listed here. I'm going to go over the important ones, which is some operators, like the bracket operator, you must implement it as a member function. Other operators, like this stream one, has to be implemented as a non-member function. Okay, quick question. So why do we implement? Do I have on the next slide? I don't. Okay, let's do one more example, where we will try to overload the alligator symbol for streams. So we go to fraction.cpp. Okay, so you can read through this. This is basically just a cute little fraction class. Let's implement a stream. Let's implement the alligator operator for streams. Okay, so that will allow us to write code like this. Okay, so what the fraction class does is it's basically just a cute little fraction class that's like here, where I declare two fractions, me and you, and then this is the problems I solve on the midterm, this is the problems you solve on the midterm, this is the total number of problems we solve together in total, because that's totally how exams work. And then you can write code like this. Okay, cool. So what was I gonna say here? I'm gonna skip this for now, and then I'll get back to this when I finish implementing streams. Okay, let's do one more example where we want to overload the what's it called, the alligator, so that we can print a fraction. Okay. Okay. So operator. Now, do we want to implement this as a member function or a non-member function? Non-member. Why non-member? Yeah. Okay. So if you think about the parameters, if this was a non-member function, it would be a stream, an O stream. Let's do std O stream. It would be an O stream, and also the fraction itself. Imagine what we would need to do to implement this as a member function. If this was supposed to be a member function, what class are we writing this function in? OStream, right? Can we actually write a member function for OStream? We cannot, because that's the STL library. We can't overwrite the STL library. Okay, so in some cases like this, where you don't actually write the function on the left-hand side, you cannot write it as a member function. So here we have to do it as a non-member function. Okay, that does pose some problems though. So, by the way, what is the return value of the alligator operator? It's an O stream. It's a reference to an O stream. Can anyone guess why? Yeah. Mm-hmm.
Isn't this why you can like keep chaining?
Mm-hmm. Yeah, because when I in some code I can write c out some fraction, but then I also want to sometimes chain them like this. The only reason this chain works is because when I, what this does is it does cout dot operator bracket of fraction 1. Okay, so it calls this thing. This thing returns a reference to a stream, a reference to cout, and that allows us to actually call that again. So this is now cout, and we call operator bracket on fraction 2. Okay, so that's why we return the ostream by reference. Always think about the semantics of these, because you can. That's what lets you determine. Okay, if someone were to actually call this operator, would they need a reference or would they need a value? Okay, how would you implement this? I'll just show you the answer. OS f dot numerator, and then f dot denominator. Okay, this is just printing the numerator / denominator. Okay, now this brings a problem. Can anyone see why this is a problem? Yeah.
Can you use the operator if you're overloading it?
Good question. So f.num itself is a int. So whoever wrote the cout or the stream class, they know how to print an int. Yeah, but they don't know how to print a fraction. So we have to tell it exactly how to print a fraction. Okay, as a hint, num and denum, what are those in the class? Those are private variables, right? So you can only access the private variables if your class, if the function you write is a member function. But this is a non-member function. So we technically are not allowed to access num and denum. Okay, yeah, I heard friend. What were you gonna say? Okay, so I hear two things. What we can either get a copy of it. So to get a copy, you can do something like you can call get num and get denum, which gives you a copy of num and a copy of denum, and then you can actually modify that here. Yeah, so we could do that. Some classes don't have that, don't have the accessors for the private ones. So there's a more general method you can do, which is friend. Do you have a question? Okay, so friend. What does a friend do? So essentially what a friend does is a function that is a friend is one that is outside of the class, but can still access your private member variables. Okay? So to do that, we declare here, inside the class itself, we declare, okay, we're gonna declare a friend called operator, bracket, which takes in ostream, os, and a, what's the other one? Fraction, const fraction. Okay? And then when we do something like this, now it declares that operator to be a friend. So when we try to compile this code over here, this function is allowed to access the private member variables of f. Cool. Okay, key takeaways from this one is... Key takeaways. First, you should always think about the constants of the parameters. So here, OS is not const, because we're actually adding stuff to the output stream. But fraction is const, because we're not modifying f. Always think about whether or not we're returning by reference. So this here, it is by reference. And then the other takeaway is friend. Okay, I have a really cute slide over here. Friend. Why do you want friends? Because they help you get through week 6. But no, the real answer is you need them to access private member variables. Okay, how much time do we have left? 5 minutes? Okay, we can get through some more. Let's talk about some general rules. So we've seen a couple examples, right? We've seen the plus equals, the plus, and the stream operators, and we've seen which ones should be done which. Let me just quickly go through the rule of thumbs for member and non-member functions. Okay, so the rule of thumb is, first, some operators have to be implemented as members. There's no way around it. So the bracket ones, the equals, they have to be implemented as member functions. There are some which you have to implement as non-members, like what we just saw, the alligator one, because you can't write into the OStream class. Okay, so you have to implement it as a non-member. For unary operators, we don't have time to implement a plus plus, but you can implement a plus plus. You have to implement those as members. Okay, here's the other kind. So if a binary operator, so like plus and less than, if they treat both operands equally, then you should implement it as a non-member. So think about plus, right? Plus treats the first operand and the second operand equally. So that should be implemented as a non-member. But if it does not treat both operators equally, mainly because it is actually modifying one of them but not the other one, for example, plus equals, in that case you should implement it as a member. Yeah. Mm-hmm.
Pretty much any time you take two inputs and modify them both, then it'd be a non-member because you can't guarantee what gets passed into the other.
Right. Mm-hmm. Take two inputs. Yes. Mm-hmm. Yeah, and especially like cases where you do want to implement it as a member, or cases like in the vector one where your one side is a vector but the other side is a string. You're not treating them equally. You're adding the string to the vector, so you should implement it as a member. Okay, there are reasons to this, but the main reason for this is if you implement it as a member, it's easier to access the private variables of one of them, of the one that you need to modify. So plus equals, we actually need to modify the left-hand side, not the right-hand side. Okay, I'm skipping around a bit. I'll reorder these slides. Okay, key summary of takeaways. Okay, POLA stands for Principle of Least Astonishment. Anyone want to guess what that means? Just take a wild guess. Yes,
Making functions act as if how you think they work.
Mm-hmm. Yeah, exactly. Basically, whenever you implement something that someone else has to use, you want to implement it so that they will not be surprised when they use it. Okay? So, here was the quote from 1984. If it has a high astonishment factor, then you should redesign it. So, some examples, some of the key rules. One is design operators to primarily mimic conventional usage. So, part of the returning by reference or labeling parameters as const, most of those are to deal with, you want to mimic conventional usage. Conventional usage usually means how primitives are implemented. Okay? So, plus equals, we assume that plus equals returns a reference to the left-hand side. For example, take a look at this function, which uses the time struct we've used many times. So suppose I overloaded the less than sign. Okay, it's pretty obvious what start less than end means, right? It means which time goes first. Okay, but think about start plus equals 10. Is it obvious what exactly plus equals 10 does? Are we adding 10 to the minute or to the hour? Not sure. If there's any ambiguity, then don't overload that operator. You should actually implement a function called change time, or not change time. Change time is ambiguous. Change seconds, not seconds. Change minute or change hour. Okay. For example, end minus minus. Again, what is it changing, hour or minute? And then finally, just something really absurd. Don't overload the comma operator and do something like that. You really don't know what that is doing. Okay? I was going to write an example where if you did something like this, it would print the fraction in ASCII art. But I ran out of time yesterday, so. But basically, yeah, you really just don't know what this does. So don't overload operators for that. For symmetric operators like the plus, where both sides are equal, you should use non-member functions. I have a deeper explanation as to why, but it has to do with symmetry. Right? If you implemented the plus as a member function where you can add a fraction to an int, this would work, but this would not work. Because this treats a as the object itself we're calling the function on, but this treats the 1 as the object, which doesn't work. Okay, so you always want to implement symmetric operators as non-member functions to avoid any these non-symmetric surprises. Okay, finally, always provide all out of a set of related operators. So what do I mean by related sets? These are all related sets. So if you implement equals equals and the less than sign, you should implement all 6 of these. Okay? Someone should not be writing code like this, A less than B, and say, okay, that works. Then B greater than A should also work. All right, don't just implement one and not implement the other one. People will be surprised. All right, similarly, don't implement plus, but not implement plus equals. Unless there's a specific reason. Otherwise, if you implement plus, you should also implement plus equals. Okay? Cool. Let's skip that. Okay, in the last, we're out of time, but I'll basically give you a look ahead of the other operators. If you want to leave, you can leave as well. But some other cool operators that we won't cover, well, we will cover maybe later. First, you'll notice that the arrow operator and the arrow star operator, these are actually operators you can overload, and that's actually what we'll do in the smart pointers lecture, which Anna will be teaching. Functors, we're skipping this, but this is basically a lambda. You can define your own memory allocators. If any of you have taken CS 107, you've written a heap allocator. You can put that heap allocator into C++ as their actual allocator. There's no reason to do that, but some companies actually want their own custom allocators to do for memory, for performance issues. So you can actually do something like this. There's more multi-threading stuff that we won't cover. There's the spaceship operator, which I wanted to cover, but we don't have time. But yeah, this is a C++ 20 thing. It's called the spaceship operator. It looks like this. It basically supports three-way comparisons between different like equivalences classes. If you've taken CS 103, you'll know what some of these mean. Anyone in CS 103 right now? Okay. Are these terms vaguely recognizable? Maybe? No? Okay. Okay. Well, Keith probably changed the curriculum a little bit, but yeah, these are like if you take some math classes, you'll understand what these mean. Essentially, the idea is some things are not comparable, so you need like a more robust way to essentially order different elements, and that's what the spaceship operator is doing. Okay. The key thing we'll be doing next time is suppose we wrote code like this. So we wrote code like this. The equal sign doesn't actually work because when we do the equal sign on this vector, so this is a vector, size 4, the elements are pointing to stuff on the heap. When you do the equal signs, what happens? When I try to copy this vector to another vector, this happens. By default, the equal signs copies every member. So here, because it's a pointer, it's just going to copy the pointer to the same place. That's a problem because suppose we tried to add a new element to one of the vectors. Then what happens is both are referring to the same vector. If you change one, you're actually changing the other one as well. Okay? This is known as a shallow copy versus a deep copy. Okay? The reason I hate Python is because Python is super ambiguous about this. Okay? Yeah. In Python, you can add something to a list. You change the original object, and the stuff in the list is modified. Okay, which is why I hate Python. But in C++, you have full control over how copy operations work. Okay, so the culprit of this all is the equal sign, and that is the topic of the next 2 lectures. All about copying. We'll talk about all the copy constructors, and then in lecture 13 we'll talk about move semantics, which is one of the coolest things I've ever learned from C++, move semantics. Okay, so make sure you come to both next week. I will say that the next 2 weeks are some of the most like conceptually involved lectures, where there is like a heavy amount of just conceptual understanding. So make sure you come with your A game. Okay. Cool. All right. Let me know if you have any questions. I'll be outside.
Thank you for the cake.
Yeah, no problem. I'll bring more next time.
So there are office hours right now?
Yes. So I'll be outside, and then you can ask questions if you have questions. Yeah.